Hello students and welcome to the review lesson on how to solve linear inequalities. And I have sort of a layman's definition for linear right here. It is any function that can be written as f of x equals ax plus b. You might have seen this as y equals mx plus b. It's just a different way of writing the same concept. Okay, as long as a and b are constants and a is not equal to 0. Okay, so this is sort of the layman's definition of a linear function. It basically means any function that can be displayed on a graph as a line, hence the phrase linear. Okay. But this review session is really about how do we solve linear inequalities. So let's look at an example here. We'll call this example 1. And I have an inequality 2 times quantity 3x, sorry, that should be a 3, quantity 3 minus 4x minus 5 times quantity 2x plus 3 is less than x minus 17. So we kind of treat this just like any linear equation, except it has an inequality symbol. So let's start by distributing everything using the distributive property here. So you have 6 minus 8x, negative 5 times 2 minus 10x minus 15 is less than x minus 17. Okay. And on the left side here, we just combine all of our like terms. So we have negative 8x and negative 10x, so that gives us negative 18x. And then 6 and negative 15, that gives us negative 9. Okay. And then we want to add 9 to both sides. So 17 plus 9 is negative 8. And then subtract x from both sides. So you get negative 19x is less than negative 8. And then in the final step, we just divide both sides by negative 19. And you get x on this side and 8 19s on the other side. Now the one thing we have to remember, and this is probably the only thing that's really tricky about solving linear inequalities, is that when you divide or multiply by a negative number, you have to flip the inequality sign. Okay, so I'll say here, when dividing or multiplying by negative number, flip inequality sign. Okay. And so our final answer is x is greater than 8 19ths. And let's just show this as a graph. So this is 0, this is 1. 8 19ths is a little bit less than half, so it's right here. It's going to be an open circle, and it's going to go towards the right since x is greater than that. Let's see if you can hit pause and write this in interval notation. So x is going to start from 8 19ths and go on to positive infinity. Okay. So there you have it, an example about how to solve a linear inequality. So that first example, we had to flip the inequality sign at the end. We erase all this stuff here. And I've posed the question here in red, why do we flip the inequality sign when dividing or multiplying by a negative? And this is something that we learn in our early algebra classes, but the reason for it isn't always clear. So let me just give you an example. Let's say you had an inequality like this. Let's say you had an inequality 8 is greater than 7. Okay, and of course we know this is absolutely true. Okay? But what happens when we multiply this? We multiply both sides by a negative number. Okay, so if we were to multiply both of these by negative 1, and we use negative 1 here as a example. So we were to multiply this by a negative number, both sides. On the left side, you would get negative 8. On the right side, you would get negative 7. Okay? And you can see now that if I were to write this greater than symbol here, it's no longer true. Okay? So I have to flip the sign and make this a less than symbol. Okay? And it's sort of like saying I have two numbers here on the number line. I have 0, let me put 0 here. Okay? It's like saying I have 0, 7, and 8. Okay, so here 8 is greater than 7, but when I multiply both of them by negative numbers, it's like they get flipped over the 0. Okay, so now you have negative 7 and negative 8, and now negative 8 is to the left of negative 7, so it's less than. Okay, so just a brief explanation there as to why we have to flip the inequality sign when we're multiplying or dividing by -1. Okay, so we'll continue with a few more examples, just some slightly trickier functions and equations. Okay, so now we have an inequality that has fractions in it. Okay, and fractions are a little bit more difficult to deal with. So this example is just about how do we use the LCD, or the lowest common denominator, to solve. Okay? And in this case, we have to find the lowest common denominator. We have 8, 2, and 3, and basically you keep multiplying each one of these numbers until you get a common result. Okay, so I think the LCD is going to be 24. 8 times 3 is 24, 2 times 12 is 24, 3 times 8 is 24. So I'll just make a note here. So in this case, LCD equals 24. So we have to ask ourselves, what do I have to multiply 8 by to get 24? That's 3. And whatever I multiply on the bottom, I have to do the same on the top. And I'm going to put parentheses around the t plus 5 because I'm really multiplying 3 by the entire quantity. Same thing here, 2, I have to multiply that by 12 on the bottom and on the top, and 3, I have to multiply that by 8 on the bottom and on the top. Okay? And once I do that, I get a new inequality. It's 3 times quantity t plus 5 over 24 minus 12 times quantity t minus 2 over 24 is greater than or equal to 8 over 24. Okay. And then the nice thing about this is, since all of the denominators are the same, we can multiply all of the terms by 24. So 24 times that quantity, 24 times this quantity, 24 times this quantity. And keep in mind that in an equation you can multiply by anything as long as you do it to every term on both sides. Okay? Once you see these, the 24s there cancel, and cancel here, and they cancel here. So we've taken away the fractions essentially, and we have this inequality. And now we just proceed as we did in the first example. So distribute 3t plus 15 minus 12t plus 24 is greater than or equal to 8. Combine the like terms. You have 3t and negative 12t, that's 9t. 15 and 24 gives you 39 and 8. Subtract 39 from both sides. You're going to get negative 31. And then divide both sides by negative 9. So t is less than or equal to 31 over 9 because we're dividing both sides here by negative 9. Okay, and remember from our last discussion, when you divide an inequality by a negative number, you have to flip the sign. And let's just give our answers. Let's box our answers. Okay, so this is the mathematical expression. Let's show the graph. So this is 0. 31 over 9 is somewhere between 3 and 4.
Morning.
It's a closed circle.
How are you?
Good morning, Mr. Golda.
Sorry.
And then it's going to extend to the left because the variable is less than. So that's showing it by a graph. And finally, this is showing it with a interval notation. And remember the square bracket because it's less than or equal to. All right, so we have one more example here, and this one uses a compound inequality. So we have two inequality symbols basically that we're solving for. And the goal here is to get all of the variables together and then isolate the variables just like you would in any other problems. But we have three parts, so to speak, to the inequality. So we're just everything that we do to all three parts. Whereas with a equation we talk about left side and right side. So we talk about left, middle, and right, and whatever we do to one part of it, we do to all of it. So I'm going to add 2 to every part. And this gives me 1 is less than or equal to 3x, which is less than 9. And then divide everything by 3. So you get 1/3 is less than or equal to x, which is less than 3. Okay? And this is your final answer. Okay? So the compound inequality is really not any different than the other inequalities. It just looks a little bit different when we graph it. So I'll put 0 here, 1/3 is probably right here, and then 3 is here. And this says that x is all the numbers between 1/3 inclusive and 3 exclusive. So this is a less than symbol, open circle. This is a greater than or equal to symbol, so it's a closed circle. Now in interval notation, we use a different color here. We would just say that the lower bound is 1/3 inclusive, and the upper bound is 3 exclusive. So we use the brackets when it's inclusive and the parentheses when it's exclusive. And so there you have it, an example of solving compound inequalities and writing them in different formats in the final answer.